This video is over topic 18, number 1 through 3, interpreting percentiles. So to interpret a percentile, you need to know the definition of percentile. A percentile is the position in a sample or population. It gives the percentage of the sample or population that have data values below the value with that percentile. So it is a percentage of the group. It is never a percentage of a data value. It is not a percentage more, percentage less. It does not answer how much bigger, how much smaller. It only tells the position in the group. So if someone's income is in the 80th percentile, one thing we can tell is above or below average. Average would be the 50th percentile. And so a larger percentile, 80th percentile, is bigger than 50. So this would be higher than average, above average. Then the next example, number 2, we have Abby is in the 90th percentile for height and Vicky is in the 40th percentile for height. We have several conclusions here. Some are valid, some are not. So I'm going to draw a little picture here of what this would look like. So if we have down here 0 would be the lowest possible, somebody that is the absolute lowest height, and then 100 it would be the highest height. Really, you would have percentiles. You couldn't have 100th percentile because the tallest person is still not taller than 100% because they're not taller than themselves. But we'll go 0 to 100. So average here would be 50th. We have Vicky at 40th. And we have Abby at 90th. Now, I've made these equally spaced as far as like counting from 1 to 100, but the percentile tells us nothing about how many people, or sorry, it does tell us nothing about the height. It's only about how many people. So if we were looking at the actual heights, you might have a very short person. Certainly, like this is the shortest person. It could jump a lot from that. And then you could have a lot that are pretty similar height. Maybe getting taller, making them tall by the neck instead of anything else. This is taller somewhat, but we don't know how much taller. All we know is that they are taller as you go from left to right. We don't know where there might be big jumps or like how much taller. Don't know anything about that. So 50% taller is trying to answer how much taller. That's no good. Looking at the percentages in these options, 40% taller, also no good. So percent taller, that's not what it says. 90% of other kids, that's okay. 60% of kids in the group, that's okay. 90% of the average height, no. We don't know a percentage of the height. This also, if she was 90% of the average height would be here. 90% of that would be below average. But we couldn't say what percentile 90% of the average height. There's no information about that. Like we don't know the actual height, so we only know their order. So the 90th percentile of the average height could be the 40th percentile, could be the 49th percentile, it could be the first percentile, just somewhere below average. We don't know. But Abby is in the 90th percentile. She is well above average. So this one would not even fit with the percentile. Abby being 50% taller than Vicky, again, we don't know how much taller she is. There's 50 percentage, we could say 50% of the group is between Vicky and Abby. 50% taller would mean whatever Vicky's height is, you take half of that, add that on, that's Abby's height. But the percentiles do not give us that information. That is not what those percentiles mean. Similarly, like 40% taller than other kids in the group here, that really is kind of meaningless because if you're going to say 40% taller than, you would have to then say a specific height. Other kids in the group, you can't be a percent taller than a plural thing. You could say than some other kid in the group. That would probably be true, but that's not what the percentile means. So that, like, even if the percentile meant a percent taller, it would have to be then a specific point. All right, so looking at the ones that have okay percentages, let's make sure they're actually true statements. So Abby is here. Is Abby taller than 90% of the other kids? Yeah. So that's exactly what this 90 means, is that these 90% are here. Abby is taller than them. So that one's good. Then 60% of the kids in the group are taller than Vicky. Again, if there are, she's at the 40th, 40% are shorter than Vicky, then that also would mean 60% are taller than Vicky. We're assuming we're treating it as though like the individual it's in a large enough group that the individual isn't like a full percentage. So we're assuming 40% above 60%. We don't have to account for like, oh, Vicky is a percentage. We're assuming this is out of maybe tens of thousands or hundreds of thousands where the individual is less than a percentage. They're not counted as anything in there. So that one is also good. Then Abby and Vicky are both above average. That is false. Vicky is below average. So that one's incorrect. And then Vicky is shorter than Abby. That is true. She's a lower percentile. She's shorter. We have no idea how much shorter, but we know she's shorter. So that's just the thing to watch for with multiple choice. Find a reason to eliminate all but one answer, or depending, look at each answer, find a reason to either eliminate or include it. For percentiles, anything that's a percentage of anything other than a percentage of the group, no good. If it's a percentage more, percentage less, anything like that, no good. So it has to be a percentage of the group and then check whether it's actually a correct statement. But then we can also give like comparison of which of the two is taller or shorter, bigger or smaller, whether they're above average or below average, that sort of thing can be said as long as you're not saying how much bigger, smaller, above, below, whatever. Then number 3, we have a newborn's head size is in the 60th percentile, and we're just going to explain this in a sentence. So you'll be doing something like this in homework activity 5, where you are playing the part of a nurse who is getting this question from the mom who has their baby's or their child's percentile height and weight. Here we're looking at head size, but just explaining this clearly, accurately, what it means. So this is there's several different ways you could say it, but the like this newborn's head is bigger than 60% of other newborns. You could be a little more detailed and say bigger, like bigger than the heads of 60% of other newborns, but I think that's clear enough. Because I don't need to say the head size in the 60th percentile means this. I just say what it means. And the other thing, when I explain, I don't need to answer why. I don't need to answer like other details that might be speculation. So I'm just explaining what does this mean? Like what is 60%? So this newborn's head is bigger than 60%. You could say this newborn's head is smaller than the heads of 40% of other newborns. And I mean, I just feel like if I say the head is bigger than 60% of other newborns, it sounds like you're saying this kid's head is bigger than the whole other newborns, which isn't right, but again, probably not necessary to spell that out. But we could also say 60% of other newborns have smaller heads than this one, or 40% of other newborns have bigger heads than this one. So several different ways that that could be expressed, but it is a percent of other newborns always. So we're not answering how much bigger, how much smaller. It's not a percent of any head size. But this is what I mean. You could also say, like, this means this newborn's head size is a little above average. Now we can say, we can quantify a little bit in that, like, 60th percentile is less above average than like 90th percentile. So if you're comparing, like, if you had two different percentiles that were both above average, you could say, like, this one is more above average than that one. So we could say 60th percentile is a little above average, understanding that that little is relative to higher percentiles. We could say, like, this newborn head size is above average. So that's interpreting percentiles.